Hello. A couple of days ago I made this comment about a video that somebody posted on the Unity subreddit about a lander game that they were making, where I said that I thought it could be done something like a quarter of the time with much better code, which I was actually meaning when I wrote, but just to make sure that I wasn't talking shit myself, I thought that I would go through the process of actually trying to do it in a quarter of the time. So this video is going to be me remaking that project, hopefully in something about 20 minutes, because I think the original there were two videos. There was the first one and the second one. In the first one they just got the lander project going, and in the second one I think they added some bullets and stuff like that. But anyway, what we're going to end up with is a little lander game where you can fly around, apply torque and thrust to the lander, fly around the terrain and shoot some bullets out the front. So, like the original video, the first thing I'm doing is just making a quick terrain. Don't really care what it looks like because it's just there for something to collide with and land on. So just random shapes all over the place. I guess if this was a real game, you probably want to import a height map from something fancy, but we're just prototyping this, so it doesn't matter at all what it looks like. After we've done this bit, then we'll start actually getting into creating the lander, which is just going to be a cube. Prototyping with shapes is absolutely the best, because you don't really care what it looks like, you just care if the gameplay is there, and then you can fix up the graphics afterwards. So we just need a little class for our lander, a little script that's going to live on that object. We're going to turn it into a prefab eventually, and this is just going to control the lander, apply the forces to it, apply the torques to it, and basically handle all the input and all the gameplay on the lander. So we need to... Oh yeah, the other thing is the camera. We're attaching that to the lander itself so that it will always follow it. So that you can see in the camera preview in the bottom right of the editor, of the scene window, sorry, you can see what the camera is looking at. So I've just parented that to the cube, so wherever the cube goes, it will always stay in the same position relative to the camera, and vice versa. So just make the lander into a prefab. We don't really need to do that now, because we're not going to be reusing this object because we're just prototyping, but I like having it as a prefab. It makes me know that it's not just a random game object that can be deleted. So starting on the code, we're moving over to fixed update instead of update because we're going to be using the physics. Generally speaking, if you're going to be doing physics stuff, then you want to be doing it in fixed update rather than update, and that's to do with the frequency with which these functions are called. Fixed update will be called, I think it's 30 times a second, regardless of the actual video frame rate that you're running at, whereas update will be called once every kind of screen update, if that makes sense. So the first thing I'm doing is just adding the thrusts. So basically, if the space key is held down, we're going to add some upwards force to our lander. So we're going to do this as a global force, which is why we're using add force, not add relative force. You could use add relative force, but it really makes no difference as long as you always apply it in the upwards direction of the lander itself, and that's why we're using transform.up. So that's the up vector of our lander. So we're always applying the force in the up direction. And then because we want to be thinking in terms of acceleration in our values, we multiply it with the mass because force equals mass times acceleration. So for our thruster force, it's an upwards vector, and then we've got the mass of the rigid body multiplied by the acceleration that we want to apply. So we want to apply a 20 meters per second squared acceleration. So this should work. No, because I didn't add a rigid body to the lander, and we need a rigid body for this. So with the rigid body attached and gravity enabled, then the lander should fall, and when we press space, it's going back up. So halfway there already. Next thing we need to think about is rotation, and that's done by torques. Torques is basically a torque is kind of an angular force. It's a little bit more complicated than that, but that's the basic gist of it. So I'm going to do these talks in local space rather than world space, which means that kind of a yawing force is always going to be a rotation around the lander's upwards vector. For example, if you were sat in the lander and we applied a yaw, it would always be like you're on a swivel chair. Whereas if we're doing this in world space, it would get quite weird quite quickly. So might rename this to local torque eventually, just so we're clear on exactly what it is. I find it's always helpful if my vectors are in world space or in local space to name them that way, because then you know exactly which space your vector is in, and if you need it in world space, then you know that you need to convert it from local space to world space. So these are local torque vectors, and I'm just applying the horizontal input to the z-axis, which is the forward axis. So basically the A and D keys are going to roll us left and right, and then on the x-axis we're going to use the W and S keys, so that's going to pitch us forwards and backwards. So basically we're rolling around the x vector, we're rotating around the x vector on the vertical input, and we're rotating around the forward vector on the horizontal input. So we just need to organize this code a little bit better so we can get the rigid body, and then we just apply that torque to it. This is all fairly simple physics stuff, just applying torques and forces. So there's not much more to say about this particular bit of code at the moment. Basically just doing the same for rotation as we did for the linear force. But yeah, I've done quite a bit of prototyping in the past, so I estimated that to get this up and running with all the physics and the controls and the bullets and stuff, I thought that would take somewhere between 20 and 25 minutes. And given that the original videos were, I think they were about an hour and 40 minutes total, or an hour and 45 or something, I said about a quarter of the time. So I think we're probably going to be on track to do that. But let's see. Just going to make those variables public so we can edit them in the inspector. And I fucked something up with the copy pasting, so that's not going to work. What's going on here? Yes, it's because we're not actually setting the Y value of local torque. So hopefully in a second I will realize that, and I will initialize local torque to vector 3.0, which is the fix for this. We know it's there, but because the Y component isn't set, it's complaining that it's not like a valid variable to be used. So we just instantiate that to vector 3.0 and it works. So now I've got the problem where the camera is rolling with the object. As the object rotates, as the lander rotates, because the camera is parented to it, and the camera is always in exactly the same position relative to the position and orientation of the lander, we're going to get the camera rolling with the object. So we're going to need to fix that. Just doing some little tweaks of the torque and the angular drag of the lander to make the feel of it a little bit better, and also the horizontal axis was inverted. So now we've fixed the inversion of the axis. We've got it feeling a little bit nicer. So the torque we're applying and the angular drag is starting to get close to what we want it to be. What we need to do is fix the problem with the camera, because ideally we want the camera to always be kind of upright. So regardless of which rotation the lander is in, we always want the camera to be facing upright. So the way I'm going to do that is by making a camera pivot, which is going to exist at the center of the lander, and we're going to add a little script to that, which I've just called camera controller. And all we're going to do to that camera pivot is just set its rotation to 0 every frame. So each frame, set the rotation of this object, which is the camera controller, which is basically just a pivot object at the center of the lander, and we just set that to quaternion.identity is basically 0 for rotators. So it helps, I find, if you add the camera controller script to the object that you want it to be on. But now you'll see as the lander rotates, the camera is staying always in exactly the same rotation. It's always pointing in exactly the same way, which is fine. The original project that we're looking at emulating had some mouse rotation on this. So I think eventually we'll add some yaw to the camera pivot, so you can rotate around the lander and have a look where you're going. Saving the scene was a good idea. Nothing sucks more than losing your work. I mean, this is a very simple scene, so it wouldn't be too bad to lose it, because we've got the lander saved as a prefab, but it's still good to save the scene usually. So we're just going to add the ability to yaw the camera around the object. That's one of the nice things about using this camera pivot method, is that you can kind of position the camera at a nice distance away from the object and rotate it so it looks at the object in a way that you want it to look at. But then you can just apply the yaw very simply to this camera controller object, to the camera pivot, and it's always going to stay at a nice distance. So now we're basically just setting the yaw of this object, or we're setting the entire rotation of this object to only be a yaw. And we're going to modify our yaw value based on the mouse inputs, if I can find the inputs. So we want the mouse X, and that's just called mouse X. So we'll just get that value, apply it to the yaw, and then we will just add a sensitivity value so we can control how fast our yawing is. We'll probably just leave it as 1 for now, because we don't care too much. All we need to do is be able to rotate it around it in some form. So the frame rate is sucking a bit because of my screen recording software, but we are pivoting properly around the camera, around the lander. So that's one of the best ways I find to make a quick prototype camera. Is just parent the camera to your object, create a camera pivot that always stays exactly at 0, 0, 0 relative to the object that you want it to be on. And then you can add a little camera control to it to make it do whatever you want. So I'm just going to add a material to the lander now, because it was getting quite hard to see. Everything was a bit washed out and blurry. We'll turn the metal slider up because I suppose landers are made of metal. So it's starting to look a bit like a lander game now. It can get quite confusing even when you crash, because you lose the ability to know. There we go. Now we have no idea which way is up for the lander. So to fix that, the original project added some cubes as legs. So we can go in and do that. Just make a new cube, and then we'll just scale it and position it. Shrink it down. Make it look a sort of leggish shape. Apply the material to it, and then we're going to need 4 of them, one for each corner. We don't want them too long. Make them a little bit stubby. So set them on each corner, and because our cube hasn't been resized at all, we know that the edges of it are 0.5 and 0.5 because it's a 1 unit cube. So rename that to leg, and then just duplicate it and set the position. I'm just using Control D to duplicate the object. Move it around. And there we go, 4 legs. So now when we play, it's going to fall down and land on the legs, which is very nice. We don't need to apply rigid bodies to each of those legs, because the root object, the lander itself, has a rigid body on it. So we'll just take into account all the colliders that are underneath it when it's doing the shape for it. Turn down the brightness a bit. So it's starting to look more and more like a lander game, and we're getting closer to the original project. And how far in are we? Something like 14 minutes, I think, we're into this. So we're well on track. Time to start adding the bullets to the game. So we'll just make a quick bullet prefab. All it is a sphere. We're going to need to add a rigid body to that eventually, but that can wait. And then for the ability to actually shoot them, we're going to add another cube to our lander, and we'll call it the gun. And basically, this is where the bullets are going to be shot out of. It's also going to give us some indicator of a forwards for our lander. So we'll make it look a little bit turret-like. Just position it properly. Apply the prefab, and then we need to go into our lander script again, and this is going to be where we start adding the bullet firing code. So we're going to need a reference to our gun, so we know where to spawn the bullets, and we're also going to need a reference to our bullet prefab, so we know what we're going to be spawning. We're going to do this in update rather than fixed update. You could do it in fixed update, but I like the separation of physics code and more kind of abstracty gameplay code, but it doesn't really make too much difference. And then we're just going to do the input like this, so mouse button 0, if that is down this frame, as in if it's just pressed down now, then we're going to instantiate our bullet prefab. I guess I should really have called that bullet variable bullet prefab, so we know it's a prefab object rather than an object in the world. That's a good habit to be in, which I apparently just skipped when I was doing this. So instantiate that object, we'll need to cast that to a game object, because instantiate just returns a Unity object rather than a Unity game object. And you can see, so we need to add the rigid body to the bullet, so it will use physics. And then in here we just get the rigid body from our new bullet, and we'll just apply a force to it. Basically just a forward force, because we've instantiated the bullet with the same rotation as our gun objects, which means that the bullet's forward direction is going to be the same as our gun's forward direction. So we can just apply a local forward force to the bullet, and that will shoot it out forwards. And we're going to, I've started off using it as an impulse here, but it's much easier if we can set the desired speed for the bullet, and then we can just do a velocity change, force mode, because this means that we've got finer control over the speed of the bullets, which is much nicer when you're trying to fix up gameplay. If you know the speed that you want the bullet to go at, it's much better to be able to set that speed directly, rather than having to fiddle around with forces or accelerations or things like that. So I've just set the parameters, or set the references rather, in the lander to the gun and bullet, or the gun and the bullet prefab rather, and then played it, and you can see the bullets are firing out. The last thing that we need to do is just add one more axis to the game, which is going to be a yawing axis, because at the moment we've only got pitch and roll control for the lander, which is fine, but we also want to be able to yaw, which is turning left and right, swiveling on the chair basically. So we're just going to make sure this is set up the same as our horizontal axis. Just make sure the values are the same. So we want to set gravity and sensitivity to 3 and make sure snap is enabled. And we'll just set this to the Q and E buttons. So the controls for the game with this done are space for thrusts, W and S to pitch, A and D to roll, and Q and E to yaw. And then on the mouse we've got the mouse x-axis is rotating the camera, and the left mouse button fires bullets. So this is the last thing that we need. There we go, you can see it's yawing now. Flying around, fire some bullets maybe. If I fire some bullets in this. Maybe put it down. There we go, fire some bullets. So at this point we are 19 minutes or so in, and we've basically recreated that other video. There's not really much more to add to this now. Just going to tweak the bullet speeds, so we're going a little bit too fast before. It's a bit nicer. And that's it, pretty much. Lander game done. I might go and do a little bit more to this game. I'm quite into multiplayer games and multiplayer programming, so I might have a tinker with the multiplayer code and make this a multiplayer Lander game, which wouldn't be too hard at all. But if there's anything else that anybody would like me to go into, or the code, or prototyping in a different way, or talking about the things that I've done here and all that stuff, then just let me know. I mean, the code isn't very hard, as you can see here. But you can just let me know if there's more things that I could go into. So that's that. Bye bye.